the medium required for transmission of sound should be in dash state. Transmission of sound should be dash state. Here coming to the waves, waves are mainly two types. Okay, waves are mainly two types. One is mechanical and another one is non-mechanical. Mechanical waves, another one is non-mechanical. Okay, mechanical and another one is non-mechanical. This non-mechanical one is nothing, you can say electromagnetic. Electromagnetic. Okay, so electromagnetic waves. So these mechanical waves are nothing but which requires medium for their propagation. Require medium for their propagation. Without medium they can't travel. Okay, so here does not require any medium. Okay, so this medium may be any of the type, that is either solid, liquid, gas, any of the type. Okay, so example you can say sound wave. This example nothing but you can say light. Okay, so requires medium means can't travel in vacuum. Can't travel in vacuum. Here can travel in vacuum. Can travel in vacuum. Okay, so the medium required for transmission of sound should be, medium is required in case of sound. Why? Because sound is a mechanical wave. That medium may be gas or solid or liquid, any of the types. So can say answer is option D. Coming to the next one, since sound wave is a disturbance which moves in the particles by setting the neighboring particles into motion, they are categorized in which wave category? Just now I have given sound is a mechanical wave, so we can give the answer as mechanical wave. Remaining are nothing but can say non-mechanical waves. In which of the following all the particles vibrate parallel to the direction of propagation of wave? Here in case of this mechanical waves are two types. One is longitudinal and another one is transverse. So in case of longitudinal waves, all the particles vibrate parallel to the direction of propagation of wave. Parallel to the direction of propagation of wave. Okay, so in case of transverse, all the particles will be vibrate perpendicular to the direction. So it is a perpendicular, perpendicular to the direction of propagation of wave. In case of longitudinal waves, some of the particles are very near to each other. So these near to each other are nothing but you can say compressions. And here somewhat of far from each other, these are nothing but you can say rarefaction. So very important question. In which wave propagation? Compressions and rarefactions are formed? That is in case of longitudinal waves. And the distance between, the successive distance between two compressions or two rarefactions is nothing but you can say wavelength. Wavelength, that is lambda. Okay, in the same way, in the transverse, we are getting all the particles will be perpendicular. Okay, so here parallel. Here this higher positive one can say crest, this negative one can say trough. So in which wave propagation crest and troughs are formed? That is nothing but in case of transverse waves. Okay, so longitudinal waves here. Why? Because they are asking the parallel. L for L. So L's are dominated na, L for L. You can remember like that. Okay, so generally the sound waves in air are longitudinal. So here waves on water surface, transverse. Waves on water surface and also light. So light also considered as a transverse wave. Okay, transverse wave. These points are very important. Coming to the next one, sound waves in air are dash. Just now I have given sound waves in air are longitudinal waves. Which of the following statement is true about the velocity of the sound with respect to the temperature? This velocity of sound velocity of sound depends on temperature. Depends on temperature. Okay, if 1 degree centigrade rise in temperature, as 1 degree centigrade rise in temperature, there is a 0.61 meter per second of the velocity is increases. That means in case of summer, higher in temperature. Summer temperature is high. So speed also high. Or velocity of sound also high. Velocity of sound also. Okay. So more in summer than in winter. More in summer than in winter. Coming to the next one. Waves on the surface of water. Just now I have given waves on the surface of water. That is nothing but transverse waves. Transverse waves. Which of the following are the areas of application of Doppler effect? What is the Doppler effect? As the distance changes, the change in apparent frequency also changes. For example, we can say the source of sound, that is train we have. If the train is moving towards the person, then what is the distance? Decreases. So the person will get high change in the frequency. High change in the frequency. If the train is moving outward from the person, distance is increases. After some time, he is not getting any change in the frequency. The change in the frequency is less. So based on this frequency changes, as per the distance changes, we can give the guidance to the aircraft. We can detect the enemy aircraft, and we can use this one in sonography. So we can say all the above. Okay, so all the above. What is the difference of two close frequencies of superimposing waves is known as dash. What is the difference of two close frequencies of the superimposing waves? So the difference in the two closed frequencies is nothing but we can say beat frequency. We can say beat frequency. For example, if we have the two waves having the very near frequencies, it is having the frequency 1. Let us take one more thing, it is also having almost very near frequency f2. So the difference in these two closed frequencies is nothing but we can say beat frequency. Beat frequency. Okay, so the answer is option A. So the answer is option A. So a person can perceive maximum 10 beats per second only. A person can perceive maximum 10 beats per second only. It is also very, very important, guys. Note it down. Okay, so that means if, for example, a music director given a lot of difference in the frequencies, but at a time, a person can perceive for 1 second maximum 10 only. If the music director has given more than 10 also, we may not perceive. Okay, so maximum we can persist 10 beats per second only. So then our persistence of 1 beat in our human brain, persistence of our human brain, each beat persist in our human brain. Our persistence of our brain is nothing but the time is nothing but 1 by frequency na 1 by 10 beats, that is 0.1 second. So each beat persists in our human brain is about 0.1 second. Is about 0.1 second. Okay, coming to the next one. Which of the following is not a mechanical wave? Not a mechanical wave means it is electromagnetic wave or non-mechanical wave. Electromagnetic wave or non-mechanical. That means which does not require any medium. Does not require any medium and can also travel in vacuum. Does not require any medium. Okay, so here light wave is the electromagnetic wave. It does not require any medium. It can travel in the vacuum also. So it is not a mechanical wave. What do we call the distance between two consecutive compressions of a sound wave? The distance between two successive compressions of the sound wave. The distance between two consecutive compressions are rare fractions, okay, or crest or thrust, whatever it may be. The distance between those is nothing but can say wavelength. It is denoted with the letter lambda. Denoted with the letter lambda. Okay, and here you can say what is the frequency. Frequency is nothing but number of cycles or number of vibrations or number of oscillations per unit time or per second. Per unit time or per second is nothing we can say frequency. Units are hertz and frequency is equal to 1 by time period. Wave number is nothing but we can say number of waves in a particular time, and amplitude is nothing but we can say maximum value or maximum disturbance on either side. For example, if the wave is propagating like this, this is the maximum value in the positive side, this is the maximum value in the negative side. This maximum value is nothing but we can say amplitude. Okay, coming to the next one. What do we call magnitude of maximum disturbance in the medium on either side of the mean value? On either side of the mean value. Just now we have discussed what is the maximum disturbance. That is nothing but amplitude now. So we can give the answer as amplitude. That is the maximum disturbance. Coming to the next one. Which of the following is the number of oscillations per unit time? Just now I have given number of oscillations or number of cycles or number of vibrations. Number of vibrations per unit time is nothing but can say frequency. So the answer is option B. So the answer is option B. Coming to the next one. Which of the following represents the speed of a sound wave? Which of the following represents the speed of sound wave? Let us take a general formula of the speed. Speed is equal to distance by time. And here in the distance is replaced with the wavelength. And 1 by time period is replaced with the frequency. Now I have already given frequency is equal to 1 by time period, or 1 by time period is equal to frequency. So speed of the sound wave is equal to wavelength into frequency. So V is equal to lambda into F, or F lambda. Lambda into F, or V is equal to F lambda. Okay, we can also say it is a N lambda, then N is the frequency. So wavelength into frequency. So the answer is option A. What is the speed of sound wave whose frequency is 2000 hertz and whose wavelength is 0.2 meter? Whose wavelength is 0.2 meter. Okay. So we know very well speed is equal to frequency into wavelength, or wavelength into frequency. They are asking the speed now. So substitute the frequency value 2000 hertz, and what is the lambda? Wavelength 0.2. So that means you are getting 200 into 2, that is 400 meter per second. So the answer is option A. So the answer is option A. Coming to the next one, guys. What is the frequency of sound wave if velocity of the wave is 200 meter per second and whose wavelength is 0.4 meter? Find out the frequency here. Use the same formula. Velocity is equal to frequency into lambda. So substitute the velocity 200 and frequency we need to find out, and lambda 0.4. So frequency f is equal to 200 by 0.4, that is 2000 by 4 you are getting, that is 500 hertz. So 500 hertz means the answer is option A. So frequency units are we know very well hertz. Okay. So 500 hertz we are getting the answer. Coming to the next one, guys. If the time period of sound wave is 0.02 second, then what is its frequency? Then what is its frequency? Yes, we know frequency is equal to 1 by time period, or time period is equal to 1 by frequency. So 1 by time 0.02, that means you can say 100 by 2, that is equal to 50 hertz. So the answer is option A, that is equal to 50 hertz. Coming to the next one, guys. If the frequency of sound wave is 100 hertz, then what is its time period? Given frequency and asking the time period. Time period is equal to 1 by frequency, 1 by 100 hertz. So 0.01 seconds you are getting. So 0.01 second you are getting. So the answer is option A. Coming to the next one. Reverberation of sound is used in dash. Reverberation is nothing but you can say multiple reflections of the sound. So this concept is used in stethoscope and also trumpet and also megaphone. So you can say all the above. Can say all the above. Coming to the next one. Frequency range of audible sound waves. Audible sound waves are nothing but you can say those are audible by human. Human can hear. Audible by human. Human can hear those frequency of the sound. Okay. So those are nothing but whenever the frequency is 20 hertz to 20,000 hertz. Within this span, we can hear 20,000 hertz. So can say 20 hertz to 20 kilohertz. 20 kilohertz. So the answer is option A. So the answer is option A. Coming to the next one. Frequency range of infrasonic. Infra means less. So we know audible. That is nothing but whenever the frequency range is 20 to 20 kilohertz. So infra means less than this low frequency. Infra means less than this low frequency. Whenever the frequency is less than 20 hertz, those are nothing but you can say infrasonic. At the time of earthquake, tsunami, we are getting the frequency is less than the 20 hertz. For example, animals like rhinoceros can listen or can communicate this by using this infrasonic sound waves. Human cannot get. So infrasonic less than 20 hertz. And frequency range of ultrasonic. So let us try to understand ultra. Where we use this word ultra? Whenever we can say ultra means great, superior, higher. Okay. So more. In these cases, we are using this ultrasonic. Am I correct? We are using this ultra word. So ultrasonic means greater than the audible range. So greater than the audible range means we know up to 20 kilohertz is the audible range now. So greater than this 20 kilohertz we can say ultrasonic. So the answer is option C. So infrasonic less than 20 hertz ultrasonic greater than 20 kilohertz. For example, let us take some bats. Bats can produce the ultrasonic, can detect the ultrasonic, and these ultrasonic waves are also used in case of medical applications and in case of sonar to detect the underground objects. Okay, so these are having so many applications. These are having so many applications. Okay. Coming to the next one, the frequency which is audible by human, so audible frequency 20 hertz to 20,000 hertz. Let us check which is in between these two. 4,000 in between these two, yes. 40,000, no. More than 20,000, no. So 4 hertz less than 20,000, 20 hertz, no. So which is audible by human? That is answer is option A, that is 4,000 hertz. Coming to the next one, the children under the age of 5 can hear the frequencies of sound up to dash. Children under the age of 5 can hear the frequencies of sound up to dash. Here what is the general audible frequency? General audible frequency 20 to 20,000 hertz. But children under 5 can hear up to 25,000 hertz. Why? Because their sensitivity is very high. Okay, as the age increases, our sensitivity of ear is decreases. Ear is decreases. So that's why we can listen up to 20 hertz only. So children under the age of 5 can listen up to 25,000 hertz also. Up to 25,000. Before the main shock waves, the earthquake produces the characteristic sound wave which some animals like rhinoceros can hear. Can you guess the kind of sound? So we know very well rhinoceros can hear infrasonic sound waves. Infrasonic means frequency less than 20 hertz. Okay, so at the earthquake also the frequency waves produced in the order of 5 hertz. So 5 hertz means less than 20 hertz. So we can say those are infrasonic sound waves. Those are infrasonic sound waves. So low frequency infrasonic. If you want to say particularly low frequency infrasonic. The sounds produced by bats. We know very well bats produce and also detect, generate and also detect very high frequencies. So that is something but ultrasonic. We know very well ultrasonic is greater than 20 kilohertz. These bats can produce up to 120 kilohertz also. Up to 120 kilohertz also. So ultrasonic sound waves. Coming to the next one. The bats can fly in the dark because of dash. The bats can fly in the dark because of dash. In the dark, they can't see enough, but they can generate ultrasonic sound waves. These are having high frequency. As the frequency is high, the time to travel will be low. So those are travels very faster. If they strike any one object, they will be reflected back, and they give the signals to the bat. They will give signal to the bat, so they can recognize there is something behind, something before those. So they have to change its direction. So they will change the direction. Okay. So like that, they can travel in the dark also. They can fly in the dark also because they generate ultrasonic sound waves. Those are travels very faster rate. So they will be reflected back whenever they strike any object. To detect the tumors in our human body, which waves are used? In all our medical applications, we may use ultrasonic sound waves. Why? Because of the high frequency, they can easily enter into our body. Okay, and we can detect the any damages in our body. So to detect, we can detect tumors in our human body. So in our medical applications, ultrasonography. Okay, we use the ultrasonography, ultrasonic sound waves. when we consider speed as supersonic speed. So all of you try to uh, give the answer. After that, check with my answer. Okay, supersonic. As the name itself, we have the answer. So supersonic means whenever the speed of object. Super. What is meant by super? Super means general meaning higher, more, superior, extra, ultra. So that means greater. So whenever the speed of object is greater than sono. Sono means sound. Whenever the speed of object is greater than speed of sono. Sono means sound. Whenever it is greater than speed of sound, we can say that is a supersonic speed. So we can say answer is option A, when the speed of any object exceeds the speed of sound. Coming to the next one, noise is measured in dash. Noise is measured in dash. We know noise is measured in decibels. Not only noise, loudness, and also intensity of sound. Okay, so all these are measured in decibels. So the answer is option A. Coming to the next one, maximum intensity of sound that can bear by human without any pain. Maximum intensity of sound that can bear by human without any pain. So we can bear the maximum intensity of sound up to 120 dB, but more than 120 dB we can't bear. So the answer is option C. If the frequency of sound increases, what happens to the pitch? This frequency and pitch both are directly proportional. So higher frequency, higher pitch. Pitch will decide the quality of the sound. It is louder or lower. Okay. So as higher the frequency, higher the pitch. The temperature increased by 1 degree centigrade, the speed of sound wave will be increased by approximately dash percentage. So the speed of sound is depends on temperature. Okay. If there is a 1 degree centigrade rise in temperature, then speed of sound is increases by 0.61 meter per second. 0.61 meter per second. So the answer is option A. So the answer is option A. Coming to the next one, velocity of sound in vacuum. Very easy, important question. Velocity of sound in vacuum. Generally, the sound wave in air is 330 meter per second. In case of room temperature, that is at 27 degrees centigrade, it will be 346 meter per second. So increases as temperature increases, it will be increases. And we know sound is a mechanical wave. Requires medium. Without medium, it may not travel. So may not travel in vacuum. It may not travel in the vacuum means it may not move means zero speed. That is nothing but we can say none of this. Coming to the next one. Submerged objects can be located by using a device dash. Submerged objects, that is under the sea. If any object is located under the sea, then how we can locate? By using the sonar. Sonar is a device used to detect the submerged objects. What is the abbreviation? SO. SO for sound, navigation, A for and, R for ranging. Sound, navigation and ranging. Okay. And we know very well laser light amplification, stimulated emission of the radiation. Okay. Light amplification, by stimulated emission of radiation. Okay, so the answer is sonar. Tachometer used to measure the rotations per minute. It is used to measure the distance of wheeled vehicles. Coming to the next one. In sonar, we use dash. So we have to detect the objects at very faster rate. And the waves must be travel very faster and they can travel very longer distances. So for that reason, we have to use the ultrasonic sound waves. We have to use the ultrasonic sound waves. Okay. A person can perceive maximum how many beats per second? I have already given what is the beat frequency. What is the beat frequency? The difference between two closed frequencies. Between two closed frequencies is nothing but we can say beat frequency. Okay, so the type of difference in two closed frequencies, we can perceive maximum 10 only. We can perceive maximum 10 only. Okay, if you have the difference in the small closed difference in the closed frequencies more than 10, then we cannot observe. We cannot perceive. Okay, so how many maximum beats per second that is perceived by person? 10 beats per second. And if the frequency is 10 beats per second, then what is the time? Time persist in our human brain. Each beat persists in our human brain. Time is equal to 1 by frequency, that is 1 by 10 seconds or 0.1 second. This is the sensation of sound in our human brain. This is the sensation of sound or persistence of sound. Persistence of sound in our human brain is nothing but 0.1. So for this, how many beats per second? 10 beats per second. Yes, the sensation of sound persists in the human brain for about dash. Just now I have given it is nothing but 0.1 second. Coming to the next one, to detect the overspeed of vehicles, police use dash effect of reflected dash waves, that is radio waves. It is also a very important one. And police use a Doppler effect. We know very well as the distance changes, then the change in apparent frequency we will get. Okay, so it is inversely proportional. The change in apparent frequency is inversely proportional with the distance. As the distance is more between the source and listener, the change in frequency is less. As the distance is less, then change in apparent frequency is high. Okay, so that is something we can say Doppler effect. Based on that one, they can get the idea of the overspeed. What is the effect on apparent frequency when the distance between the source of sound and listener is decreased? Just now I have given, so the change in frequency is inversely proportional with the distance. Here they have given distance is decreased, so change in apparent frequency is increases. So the answer is option A. So the answer is option A. Okay, for example, you can understand this one. If it is a source of sound, let us take a train. Here we have one listener is there. Okay, so now the train is moving towards to the person. That means distance is decreases. As the distance is decreases, the train is coming near to the person, means he is getting high frequency of the sound. So the change in frequency is increases. Okay, that is inversely proportional you are getting. That is the thing I have given. For example, if the train is moving in the opposite direction side, then what is happening? Distance is increases, the change in frequency is decreases. Okay, the change in or the effect on apparent frequency is decreases. Coming to the next one, the effect of multiple reflections of the sound is dash. This is nothing but a definition of the reverberation. Reverberation, generally this concept is used in case of stethoscope, trumpet, megaphones. We are using this concept of reverberation, multiple reflections of the sound. The speed of sound in air at room temperature is dash. Speed of sound in air at room temperature is dash. This generally, if they are asking speed of sound, you can say approximately 330 or 332 meter per second. So if they have specially mentioned in case of room temperature, we know very well as temperature increases, speed of sound is increases now. It is nearly for 1 degree centigrade rise in temperature, there is a 0.61 meter per second of the velocity is increases. So for the room temperature, it is 346 meter per second. 346 meter per second. So can you the answer as option C. So this is in case of air. Okay, in case of water, it is in the order of 1500 meter per second. In case of metals, it will be higher. Okay, 5000 to 6000 like that. For example, in case of aluminium, it is nearly 6420 meter per second. Very, very high. Okay, aluminum is the metal. So in the metals is higher. Why? Because the density is very high density we have. All the particles are very near to each other, so it can be travel very faster. Okay, so in case of air at room temperature 346 meter per second. Coming to the next one, speed of sound in distilled water is dash. Speed of sound in distilled water is dash. Just now I have given in case of water it is in the 1500 watt order. So distilled water 1498. In case of seawater, it is more than 1498, nearly 1526 like that. Okay, so these are some approximation values. Earthquake produces dash waves. In the previous session, I have given earthquake produces the frequency in the order of 5 hertz. So it is a less than 20 hertz means you can say infrasonic. Okay, but with respect to 20 hertz, 5 hertz is very less, so that's why you can say low frequency infrasonic wave. So the answer is option C. Okay, coming to the next one. In the following, which waves have low frequency spectrum? So here, radio waves having the low frequency spectrum and gamma rays having high frequency spectrum. These radio waves having a low frequency. Okay, these are also can say short waves. Here, which of the following electromagnetic waves are produced due to radioactive decay of the nucleus? So here, which of the following electromagnetic waves which are produced the radioactive decay of the nucleus? Those are nothing but gamma rays. These gamma rays are produced due to the radioactive decay of the nucleus. The amount of sound energy passing each second through unit area. So sound energy passing through unit area. Unit area is nothing but we can say intensity of sound. Pitch is nothing but it will give the quality of the sound, that is louder or lower, and music is pleasant sound, and note is nothing but mixture of several frequencies. So the answer is intensity of the sound. The sound of single frequency. Very, very important question. So the sound of single frequency. So in general conversation, so whenever we have grouped together and we are discussing about the music, about the voice, then we can say that so and so person tone is very good, so and so person tone is not good. Okay, so and so person tone is very pleasant. Okay, like that we are talking. So that means each person having their own tone. Am I correct? Each person having their own tone. That means their own frequency. So that single frequency, sound of that single frequency is nothing but we can say tone. Sound of that single frequency is nothing but we can say sound. Tone. So if multiple frequencies, or you can say mixture of frequencies, mixture of several frequencies, you can say that is a note. For example, music directors, they have their own note like this. Okay, the note is there, that is mixture of, it will use the mixture of several frequencies. Okay, so next question, Note is dash. Just now I have given note is nothing but mixture of several frequencies. So the answer is option A. Tone is the single frequency. Note is the mixture of several frequencies. A television channel is characterized by dash. Frequency, velocity, physical dimension and size of the picture. So whenever we scan the channels, whenever we scan all the channels, on the bottom side you can get the frequencies are variable in the edges. The frequencies are variable. As the channel varies on the screen, on the bottom side frequencies also varies. Okay, that means each one particular frequency is attached to that particular channel. So if you are changing the frequency, then your channel is going to be changed. Your channel is going to be changed. So the television channel, not only television channel, radio channels, for example, Red FM, that is Red FM 93.5, okay, FM 89.5, Radio Mirchi, like that we have so many radio channels are also there. Those are also categorized by particular frequency. So frequency of the transmitted signal. Loudness measured the sound energy reaching the air per second and depends on the amplitude of the sound wave. What is the unit used to measure the loudness of the sound? In the previous session, I have already given noise, loudness, intensity of sound. Intensity of sound. All are measured in decibel. In decibel, dBs. So the answer is option D. So use of loudness of the sound, decibel. We can bear up to 120 dB without any pain. More than 120 dB, we will get the pain. You must have seen the doctor checking the sounds produced in the chest or heartbeat of a patient using a medical instrument called stethoscope. And what principle does this stethoscope works? In the previous session, I have given the stethoscope works on the multiple reflections. I mean reverberation. Reverberation concept. That is multiple reflection. Multiple reflections. So the answer is option B.